A man peers through a small crude lens. The stars above, once distant and untouchable, now reveal their secrets. One telescope, one mind, one revolutionary truth that would shake the heavens and the earth alike. This is the story of Galileo Galilei, the father of modern science, the man who dared to challenge the cosmos itself. Galileo Galilei was born on February 15th, 1564, in Pisa, Italy. His world was a tapestry of art, philosophy, and faith. The Renaissance had ignited curiosity, yet the church held sway over truth. Scholars debated Aristotle, yet the stars, the planets, and the laws of motion were largely mysteries. Into this world came a thinker with unquenchable curiosity, whose methods would lay the foundation of modern science. His life was more than discovery. It was a battle between observation and dogma, reason and authority. Galileo was the eldest of 6 children. His father, Vincenzo Galilei, was a musician and an intellectual. Though not wealthy, the Galileis valued learning, music, and questioning tradition. Young Galileo absorbed these lessons like a sponge, developing a restless mind and an insatiable curiosity. Italy in the late 16th century was fragmented. City-states like Florence, Venice, and Pisa were cultural powerhouses. They nurtured the arts, sciences, and philosophy. Wealthy patrons funded painters, architects, and inventors. Galileo's early exposure to this environment sparked his fascination with mathematics, music, and mechanics. At the age of 17, Galileo entered the University of Pisa. Initially, he studied medicine, following his father's wish, but numbers and geometry called louder than anatomy. The teachings of Aristotle dominated the curriculum, yet Galileo questioned them. He observed the world with a critical eye, noting discrepancies between textbooks and reality. Aristotelian philosophy was everywhere. The heavens were perfect and unchanging, the earth was at the center of the universe, and motion was simple and predictable. But Galileo began to suspect otherwise. He watched pendulums swing, objects fall, and vibrations resonate, uncovering patterns that contradicted accepted thought. These early experiments, often conducted in secret, planted seeds of revolutionary ideas. The church influenced nearly every aspect of life. Religion was intertwined with politics, education, and morality. Challenging established science was not just intellectual, it was dangerous. Galileo's insight that observation and mathematics could reveal truth, independent of authority, was a radical notion. By his 20s, Galileo had started developing instruments to measure and observe, a rudimentary compass for surveying, and later an improved version of the telescope, would place him on a collision course with the powers that governed both faith and knowledge. His early experiments on motion, acceleration, and gravity, the rolling balls on inclined planes, the careful timing of pendulums, foreshadowed a lifetime of discoveries. Philosophically, Galileo drew inspiration from the Renaissance humanists who believed in the potential of human reason and inquiry. He absorbed the works of Copernicus, who proposed a sun-centered solar system. While many dismissed Copernicus as theoretical, Galileo saw an opportunity to test it, to observe, and to measure. His commitment to evidence over tradition, reason over dogma, would define his life. By the 1590s, Galileo had begun gaining recognition. He taught mathematics in Pisa and then in Padua, where he refined his instruments and observations. He was charismatic, challenging students to think critically, to question, to experiment. Yet behind the acclaim, the seeds of conflict were already sown. The society that celebrated art, music, and philosophy could not easily accept a man who questioned the cosmos and, by extension, the church itself. The origins of Galileo's journey were not born in a vacuum. They emerged from a confluence of Renaissance culture, intellectual daring, and personal brilliance. His socio-economic background gave him the tools. His philosophical courage gave him direction. And his early experiments lit a spark that would illuminate the heavens for generations to come. By the turn of the 17th century, Galileo was poised to gaze beyond the skies, to challenge centuries of accepted wisdom, and to step onto a path that would forever change humanity's understanding of the universe. By the early 1600s, Galileo Galilei had begun to make discoveries that would challenge centuries of accepted wisdom. Pause. The heavens, once seen as perfect and immutable, were revealing flaws and wonders unseen by any human eye. In 1609, news of the invention of the telescope reached Venice. Galileo, ever the innovator, immediately set to work improving it. Within months, he had crafted an instrument capable of magnifying distant objects 20 times. What he saw through that lens would ignite both awe and conflict. Galileo turned the telescope to the night sky. He discovered mountains and craters on the moon, revealing it to be far from the smooth celestial orb described by Aristotle. He observed the Milky Way, teeming with countless stars, challenging the notion of a finite universe. Most astonishingly, he identified 4 moons orbiting Jupiter, worlds clearly not revolving around the Earth. These observations supported the Copernican theory. The Sun, not the Earth, was at the center of the solar system. But in a world where the Church dictated truth, this was dangerous knowledge. Galileo's discoveries earned him fame and admiration. In 1610, he published Sidereus Nuncius, or the Starry Messenger. It spread across Europe, capturing the imagination of scholars and the public alike. Venice celebrated him, the Medici family welcomed him as their court mathematician, and students flocked to learn from the revolutionary thinker. But admiration brought scrutiny. The Catholic Church, guardians of doctrine and cosmic order, grew wary. The heliocentric model threatened both scripture and authority. Debates erupted in academic circles. Traditionalists insisted on the Aristotelian Ptolemaic view, Earth stationary, heavens perfect. Reformers, inspired by Galileo, argued for evidence over ancient text. Galileo's methods, careful observation, measurement, and mathematical description, were revolutionary. He did not simply theorize, he demonstrated. Experiments with inclined planes measured acceleration. Pendulums revealed uniform motion. These tangible proofs lent his astronomical discoveries undeniable credibility. Conflict intensified. By 1616, the Church issued a formal warning. The Copernican model could not be defended as literal truth. Galileo was ordered to abandon the idea. Yet he continued his work discreetly, convinced that the universe revealed itself through careful observation. The stakes rose further in 1623. A new pope, Urban VIII, sympathetic to scientific inquiry, seemed to offer Galileo an opportunity. Galileo cautiously published Dialogue Concerning the Two Chief World Systems in 1632, framing the heliocentric model as a debate between two perspectives. But the subtle advocacy for Copernicanism did not go unnoticed. The Church responded. Galileo was summoned to Rome to answer charges of heresy. The trial was a spectacle of intellect and authority. Scholars debated, witnesses testified, and Galileo defended his observations with courage and reason. He argued that the Bible speaks to spiritual truths, not scientific facts, and that observation should guide understanding of the natural world. Yet the result was inevitable. In 1633, Galileo was found vehemently suspect of heresy. He was forced to recant and spent the remainder of his life under house arrest. The Church banned his works, and the world lost direct access to the man who had dared to look through a lens and see the truth of the universe. Galileo's story was not only about astronomy, it was a clash of worldviews, observation versus doctrine, evidence versus authority. He had ignited a debate that would persist for centuries, a debate about the right to question, the nature of knowledge, and the courage to see what others refuse to see. Even in confinement, Galileo continued to work. He studied motion, wrote about mechanics, and inspired generations of thinkers. His conflict with the Church marked a turning point, not the end of inquiry. The rising action of his life, the discovery, the debate, the trial, set the stage for the climax, a confrontation between dogma and science that would resonate across history. By the 1630s, Galileo Galilei had become a symbol of inquiry, curiosity, and the courage to confront authority. His discoveries, moons orbiting Jupiter, the phases of Venus, craters on the moon, challenged centuries of celestial belief. But the confrontation with the Church was approaching its peak. The publication of Dialogue Concerning the Two Chief World Systems in 1632 was a bold move. Galileo framed his arguments as a debate between a geocentric defender, Simplicio, and a Copernican advocate, Salviati. Beneath this literary device lay a clear endorsement of heliocentrism. The Pope, Urban VIII, who had previously supported Galileo, felt personally mocked. Political and religious tensions escalated. In 1633, Galileo was summoned to Rome. The Inquisition awaited. His trial was a dramatic confrontation between observation and authority. Courtrooms filled with scholars, clerics, and officials, all attentive to the debate over the universe itself. Galileo argued passionately that the Bible teaches how to go to heaven, not how the heavens go. Yet in the face of political pressure, he was forced to recant. He uttered the famous words, "Eppur si muove," and yet it moves. Though likely whispered later rather than in court, the phrase embodies Galileo's unyielding commitment to truth. His trial, recantation, and subsequent house arrest marked a turning point, both tragic and monumental. House arrest did not silence him. Confined to his villa in Arcetri near Florence, Galileo continued to write, experiment, and correspond with students and scientists across Europe. He studied motion, perfecting the concept of inertia. He explored the laws of falling bodies and pendulums. In 1638, he published two new sciences, summarizing his pioneering work on kinematics and material strength. Galileo's resilience under house arrest revealed his dedication to science. Despite restrictions, he refined methods that would become fundamental principles in physics. His work influenced future thinkers such as Newton and Kepler, establishing a new standard for empirical inquiry. This period illustrates a pivotal clash, the individual pursuit of truth against institutional control. Galileo's observations were undeniable, yet the power structures of the church and society sought to suppress them. His life in confinement became symbolic, a testament to human curiosity persisting in the face of oppression. Galileo's reputation spread across Europe. Scholars debated his findings, replicating experiments and expanding knowledge. The heliocentric model gained traction. Though controversial, the seed of modern science had been planted. Galileo's methods, systematic observation, measurement, and mathematical description laid the foundation for the scientific revolution. The climax of Galileo's life was not only personal, it represented a broader shift, the transformation of human thought. The tension between dogma and reason, tradition and evidence, would continue to define scientific progress. Galileo became a beacon, a reminder that observation and reason could illuminate truths beyond established authority. In the quiet of Arcetri, Galileo continued his experiments, shaping the principles of motion and mechanics that still inform physics today. His pivotal struggle with the church, his unwavering dedication to evidence, and his intellectual bravery mark the climax of a life devoted to discovery, a life that would leave an indelible mark on humanity. Galileo Galilei died on January 8, 1642, in Arcetri, near Florence. He was 77 years old, confined by house arrest, yet free in spirit. His life had been a relentless pursuit of truth, an unyielding quest to understand the universe. And though he faced opposition, his discoveries reverberated across centuries. Immediately after his death, Galileo's work inspired both admiration and caution. Scientists and philosophers continued to grapple with his findings, testing, replicating, and refining them. The heliocentric model, once suppressed, gained credibility. The principles of motion he articulated became essential to the emerging field of physics. Galileo's methods, observation, experimentation, mathematical analysis, laid the foundation for modern scientific inquiry. Newton, centuries later, would build on Galileo's insights, formulating laws of motion and universal gravitation. Without Galileo, the scientific revolution might have taken a vastly different course. But Galileo's legacy was more than science. It was a declaration that evidence matters more than tradition, that curiosity should not be stifled by authority, and that human reason has the power to unlock nature's secrets. His courage in the face of persecution became a symbol for intellectual freedom. The conflict between Galileo and the Church echoed across Europe. It raised fundamental questions about the nature of truth and the limits of institutional control. Scholars, thinkers, and eventually societies began to recognize that knowledge should be guided by observation and reason, not solely by doctrine. In the centuries following his death, Galileo's ideas permeated education, philosophy, and science. Observatories were built, telescopes refined, and the cosmos mapped with increasing precision. His discoveries, once controversial, became foundational to astronomy, physics, and engineering. Galileo's influence extended beyond the sciences. He inspired artists, writers, and thinkers to question, to explore, and to innovate. The spirit of inquiry he embodied helped define the modern world, a world in which curiosity is celebrated and exploration encouraged. In the 20th century, the Church itself acknowledged Galileo's contributions. In 1992, Pope John Paul II formally recognized the errors made in condemning him, almost 350 years after the trial. History had vindicated Galileo, confirming the timeless truth. Facts revealed by nature cannot be silenced forever. Galileo's life reminds us that progress often comes at a cost. It takes courage to challenge prevailing beliefs, to look beyond what is comfortable, and to follow evidence wherever it leads. His telescopes, manuscripts, and experiments are symbols of a mind that refused to accept limits. So when you look up at the night sky, remember Galileo. Remember the man who taught us to observe, to question, and to never fear the pursuit of truth. Let his curiosity inspire yours. Explore, experiment, and above all, never stop asking why. Galileo Galilei, astronomer, physicist, philosopher, revolutionary thinker. A life that changed not just the understanding of the universe, but the very way we think about knowledge itself.